Thank you. Good morning, everybody. We're going to get started talking about freaking. It's not a very, very technical speech, but it's a bit more than introduction also. I hope I will get your interest, and I would like to thank everyone who participated in the organization of HITB. They're doing a great job. So, let's get started. Now, how does that work? Oh. Just a little disclaimer to, actually I'm not going to give out any freaking exploits like was just mentioned, but I just wanted to mention that everything that is being discussed here is not illegal, of course. How does that work? So the agenda is, I hate that thing. The agenda is basically we're going to have a brief introduction about freaking. We're going to review a bit the digital telephony concept. We talk about network element security, network elements for each telecom operator. We're going to look a little bit into protocols, and we'll look at future threats, or actually existing threats, I would say. So, once upon a time, I would like to give a lot of credit to John Draper, also known as Captain Crunch, who is here in the audience. A big clap for him, please. Now, John is one of the original freakers. He was freaking when I was 2 years old, right? It's just to tell you how experienced he is compared to me. This is a picture taken during the 80s, and believe me, at that time it was really a great day for freaking, really good stuff. This doesn't work. What is freaking? I mean, you know about hacking, of course, because it's very popular in the news. It's being talked about in every single press report you can imagine. Hack everywhere. Everybody knows about buffer overflows. But freaking is not so well known. And what is it? Basically, it's abusing telephone systems, or not really abusing, but making them do things they're not supposed to do. It's mostly about exploration, about discovering what the telecom systems can do. Telecommunication systems are very complex. Now, you don't realize that when you take your phone and you make a phone call, everything works, but believe me, there's a lot of computers, networks, protocols that are involved in making just a simple phone call. It's a very complicated system, and that's why it's worth exploring. It's about controlling network elements. Network elements, maybe in my speech you see them referred as NEs. They're basically the building blocks of telecommunication infrastructures. And there's a lot of them in telcos, and there's a lot of them that can be abused. And well, we're going to see how we're going to abuse each of their protocols. Now, why would you do this? Well, I will quote Captain Crunch again from the Esquire October 1971 article, which I actually have the original. I'm going to get it signed by Captain Crunch. You do it because you want to explore. You want to explore the telecommunication system, and you realize that the phone company is nothing but a computer. Now, that's a very interesting quote. You don't realize that, but actually, all the telecommunication networks, they form a huge computer. They're all interconnected. Of course, they're made of many computers, but they represent a large, very large computing system. That's what they are very worth exploring. Just a little word of caution before we get started. I like that word of caution. It was written in 1992 by some guy in the 2600 magazine. And it says that if you live in a currently repressed area, such as the United States. Now, I thought that was quite funny to write that in 92. I wonder what the guy would think now. But anyway, that's out of the discussion. You should be aware that this can get you into trouble, like hacking can. So, you know. So the blue box is the original freaking device. Now, you might have heard about the blue box because it was quite popular for some time. That's one of the original blue boxes, and you can see also Steve Jobs and Steven Wozniak, you know, the Apple founders, are playing with blue boxes. Now, those guys started selling them in university and playing around, and well, they did pretty well. The idea of the blue box was to abuse the CCITT number 5 signaling protocol. At that time, all the signaling was done in band. What does that mean? In band means it's the same frequency as the voice, which means if you had the right tones, and if you could put them in the speech channels, then you would be able to control the switches. Now that's basically the idea, right? So you would first send 2,600 tones, of course there are variations of those frequencies, to release the trunk, to basically tell the trunk that you're making a call, and you release the trunk, and the telecom system believes that you have hang up. The other side of your call believes that you're still there, and you then send a seize followed by a KP1 and dialing, which starts instructing the trunk to dial any number. And that's a good part of it, is that since the switch you are on thinks you've hung up, you have no charge. That's the idea. Basically, you make free calls. It's not the main point of using a blue box, but that was one of the nice side effects. Another interesting feature is that you could get access to all the advanced features that operators only have access to. You could choose if you went cable, if you went satellite, you could stack operators, you could organize conferences. There were a lot of voice conferences organized in the late 80s, early 90s, at least in Europe, where I used to play with these kind of things. But as you see on my slide, it became popular in the late 60s. I think the earliest reference date I found for a blue box was in 1968, but I'm not sure. I was 1 year old. Basically, you produce the tones that were needed for freaking using dialers, like the one pictured here, or you could use the computers. Obviously, once computers became popular, they could generate tones, and there was the most popular vector for blue boxing, at least in Europe at that time. Now, blue boxing is not really working anymore, and the reason it's not working anymore is that we're not using the in-band signaling. We're using out-of-band signaling. I didn't clarify what signaling is, but basically signaling is just controlling the call setup, call release, etc. You, as users, you do signaling when you dial your telephone number. When you take your phone off hook in your fixed line, you just tell the trunk, I'm going to start dialing. Then you dial with your keypad. That's signaling. There's not only user signaling, there's also, of course, inter-trunk signaling between the different telco offices, and that's what blue boxing was all about. It was about using trunk signaling on a speech channel. Of course, the telcos were not very happy about it. In the States, they started prosecuting, they started putting filters, they started changing frequencies, everything they could to stop the fraud. But from what I know, nothing really stopped it. People found new frequencies, they avoided prosecution, they became careful. So eventually they came up with a new protocol, the so-called SS7 protocol, which is the CCITT number 7. Now it's called ITU, but at that time it was called CCITT. And the SS7 is what we call out-of-band signaling. Out-of-band means you can't speak it. You don't have access to it as a user. Your channel where you speak is a different channel that controls the network. The SS7 network is actually entirely digital. CCITT5 was analog, of course, since you controlled it by frequencies, by sound, it had to be analog. But the SS7 is totally digital. And since you don't have access to it directly, then you don't have the possibility to blue box with SS7. It's just a network that is out of your reach. So those SS7 switches were rolled out in the 80s, in the 90s, and now pretty much everywhere we're using SS7. There are still some countries that are still using some R2 and CCITT5 signaling. I won't tell you which one, otherwise you'll start boxing tonight, but there are a few of them, and not so far from here. As far as I know, there were some blue boxers in KL. At least I met one in '95. So, there were freakers in Malaysia, and '95, that's quite a while ago. So, this is not a new discipline by any measure. What's the difference between a hacker and a freaker? Well, that's very difficult to quantify, but what happened is that in the late 90s, the internet started growing much faster than it has in the beginning. Nobody knew about the internet in the 80s or in the early 90s, but at that time, it started growing and everyone knew about it. And because of the web, people had access to exploits, had access to security research on the internet, TCP/IP vulnerabilities, etc. So a lot of attention was diverted from the traditional underground scene, which was mostly made of the BBSs, X25, and things like that, and moved into internet hacking. So basically, the internet growth has taken away the attention from all the phreaking scene. Yeah, and as I wrote in my last line, it's not about, phreaking is more about discovery and about experimenting. It's not just about running the latest exploit that you didn't write most of the time, right? So it's not a technique that you can just download a tool and push click or scan or whatever and it's gonna work. It will require a bit of time before you can actually do something interesting with it. Right. So let's start talking a little bit about digital telephony. Now, as we've seen, we moved from analog signaling system like CCITT5 to SS7. And with this, it was also a big development in digital telephony itself. Now, when I say digital, I mean all of you are using those GSM mobile phones, and they're all digital. But before that, they were analog mobile phones. The fixed line network can be considered an analog network, but in fact, it's all run by digital computers. All the switches are made of a lot of computers. So digital telephony basically had a huge growth in the recent years. Where's my water? So I've got a picture of a switch room here. Now that just to show you what kind of environment we work in when we work in a switch. It's very silent. Now when I think all those phone calls that are made simultaneously, the room itself is very quiet and also very cold. It has to be all air conditioned and like working in those big data centers. What you see over there is probably some switch, some MSC as we call them, mobile switching center in the mobile industry. You've got a lot of racks and they're all interconnected with big data trunks. Everything is basically like a big computing environment with digital networking. So what do we have? We have the fixed line, traditionally known as the PSTN. And in the fixed line, we've got the digital network called ISDN, which I'm sure some of you are familiar with. Right? The ISDN is basically having a digital line that connects you to the central office, whereas the PSTN, traditionally, you're just connected with a copper wire. Right? If your line at home is a normal line, it's very much analog. You're connected to the central office via copper. If you have ISDN, you've got a digital connection, and you also have an SS7 connection. There are also many mobile systems. In the beginning, there was an analog system, mostly used in the United States and Northern Europe, like AMPS or NMT, and those systems are pretty much obsolete now. They served their purpose at the time, but as you know, in the States, it was so easy to intercept analog phone calls and to clone the serial numbers, and you could have free phones on the bill of somebody else, and there were a lot of problems with authentication, etc. So in Europe, they started that big consortium that developed the GSM digital system. That was in the very early 90s, and most big telecom vendors in Europe were involved in specifying the protocols. That's why GSM grew so fast, because there was a need for an advanced mobile telecommunication system, and the American system wasn't really well suited. So GSM grew very fast in Europe and also in Asia. I think it's because the European vendors, they came to Asia and sold the business before anybody else could. And nowadays, GSM is the most prevalent telecommunication system. It's, of course, evolving. Now we'll see that there are some other protocols and there are some other standards coming on the market. But at the moment, it's a predominant. It's moving towards the 3G, that we're going to talk a little bit about this. My speech is mostly focused on the GSM/3G infrastructure because it's the most common in Asia. My observations will be the same for a CDMA network. There's not so much difference. Of course, there are also some private networks, like the one used by the police, the hospitals, the military, etc., and that we're not going to look into that. All the switches are speaking SS7, you know, the signaling protocol. You're going to hear a lot about this today. And because of that digital signaling protocol is used everywhere, it's become very difficult to phreaking. Another important area that is very related to the security of those systems is that the increase of application and systems. Now, I'm sure that you all very well know that all the operators are offering a multitude of services, from e-banking to email, web, WAP, ringtones, etc., right? What people fail to realize is that basically their phone is a computer, and the operators are just service providers, and computers are targets of hackers eventually. Now, it's not very well developed now. There's already been a couple of mobile phone viruses, I think 2. Now that's to be compared with the, 30,000 that exist for PCs, just to tell you where we are in the evolution chain, right? But don't get mistaken. This is a medium that the hackers and the virus writers will be interested in. Yeah. Now let's get a little bit technical. Now I just want to explain you how the infrastructure of a network operator is working, because otherwise it's kind of difficult to understand all the parts. Basically what we have, here I've put the 3G and the GSM, right? Mostly they work the same way. There's a radio part, which in 3G is called RAN, Radio Access Network, and in GSM is called BSS, Base Station Subsystem. But basically it's just a radio access. It's just for you, your mobile phone contacts the next tower, and then sends all the stuff to the switch. The switch, which we call mobile switching center or network subsystem, is at the bottom right. Now you see it connected to the VLR, which is a visitor location register, the subscriber database, and it's talking to other machines like the EIR, the equipment identity register. All your phones have a serial number that is stored in the EIR. So when it is stolen, they can check against the stolen database. The funny thing is that in practice, most of them don't do that, because the telecom operators, they don't really care if you're using a stolen phone as long as you pay your bill. They are very good at taking your money. So SMSC is the part that sends us short messages, and now, of course, we have also the MMS protocol. The MMSC is going to sending those multimedia messages. So HLR, the home location register, is basically the main database. It contains all the information concerning you, well, not you, your subscription. It doesn't store any of your details. Those are stored in the billing system. It just stores details on your subscription. What kind of services you are allowed to use, are you able to roam, etc. On the right-hand side, you see the AUC, the Authentication Center. The Authentication Center is storing all the cryptographic secrets that are used for the authentication in GSM or in 3G. Unlike the early analog phone systems, GSM is strongly authenticated. When you start making a phone call, first you are attributed a temporary identity. It's not even your real number that is over the air. And with that temporary identity, you're going to have a challenge response protocol to make sure that you are the real owner of the phone. There is a cryptographic secret called the KI that is stored on the SIM. It's a bit the equivalent of a private, your private key in a public, public key system. Like, if you're familiar with PGP, you know that you have a private key and that you can encrypt messages in an asymmetric way. Well, the KI is pretty much the same for mobile phones, right? So if someone gets access to your KI, it's the same as someone getting access to your PGP, your private key, right? Basically, they will be able to decrypt messages and they will be able to forge messages. So the AUC is a very important part of the telecommunication network, at least when security is concerned. What else do we have? Well, we have also on the upper right, we've got all the packet data stuff, which is a recent addition to the GSM protocols. First, the mobile data was basically circuit switch data over GSM, right? They were just emulating a speech channel to talk to an analog modem. So before, when you connected using GSM to I must request that the CTF participants report to the registration counter immediately. So you know who you are. I don't. So yeah, I was saying that mobile data initially, and as an anecdote, I would like to say that my first speech about this kind of topic was here in Malaysia in '96. And at that time, believe me, mobile data was very much in its infancy. But it was still existing. You could connect to a modem and you know, a dial-up server or whatever and get access to the net or do something like that. But it was basically taking an analog connection and encoding it in a digital format that GSM could understand, and it was very slow. It was limited to 9.6K, right? Just like the early modems. So now we've got that thing called GPRS, right? You've all heard about it. I'm sure it's advertised everywhere in Malaysia. GPRS is a transition technology moving to 3G. The idea is to, you know, the operators, they cannot move from one day they are GSM and the next day they are 3G. And you, the subscribers, cannot do that as well. You have to get used to mobile data, right? So that's why they introduced GPRS and WAP as well. These kind of protocols are used as a transition technology. Now, GPRS introduced an IP backbone in the telecom operator. So basically, you can do packet data, not circuit switch data like a modem call would be, but packet data like the internet is from your mobile phone, which means you can have a permanent connection. Permanent connection is permanent, like, well, you know, you've got an IP address, and your phone becomes basically a target that can be reached from the internet, so you can imagine all the security exposures that are created from that. Well, GPRS is made of a few network elements like the GGSN, which is nothing but a fancy router, and the SGSN, which interfaces with the radio network. What other important elements do we have here? Yeah, I forgot to mention the management thing, what you see, the OMC, NMC, TMN at the bottom right. Basically the systems that are controlling the network, and we're going to talk a little bit more about them. I notice I've got a laser pointer. Yes, good. Right. So what we're going to do now, we're going to look at the network elements that I've just described briefly, and we're going to look what are their problems, or how can they be abused, and how they're used a little bit as well. So we're going to start talking with the radio access network, then we'll move down the network elements. We'll speak a little bit about the support systems like mediation and billing, because they're very important when you consider the security of it. We're going to start with the radio access network. Now, I just wanted to show you a picture of, those are GSM antennas, right, in case you didn't know it. They are all over town, and I'm sure you've seen a lot of them. Now, those are the antennas your mobile phone is talking to, right? And then the traffic from those antennas is usually relayed by what we call transmissions. Most of the time, microwaves. They look like, you know, little drums. You see them on some towers. All the traffic is encrypted. Now, encryption is one thing. Now, you must understand how the crypto was done in GSM in the first place. They thought that they knew better than anyone, and they were going to make their own cryptographic algorithm and keep them secret. Yes, good idea. Cryptography and secrecy doesn't work together. Maybe for the military, maybe for the NSA, but not with mobile phone operators that have to share those secrets with the operators, because eventually those secrets will leak, and they did. And when they did, people started studying how they could be abused. And there were a few vulnerabilities that were found, like in the checksum algorithm, the COMP128, in the A5 algorithm. So in the beginning, people starting to publish vulnerabilities, how to clone a SIM card if you have access to it during 8 hours. And then a year later, there was suddenly, you only did it for a few seconds. And recently, I think a few months ago, some Israeli researchers have demonstrated how you could actually clone a SIM over the air, which means you don't need access to the SIM. So, of course, the GSM Association reacted and started improving the algorithm, and they've released a new version of the A5 algorithm that was the main culprit. Now, the problem with operators is that, you know, by the time you get a new algorithm, it's not like your Windows patch or Unix patching, which you can do the next day. For operators, they're going to first start testing the algorithm for half a year, and then push it to the operators who are going to say, no, we don't want it now, we want it next year. And when they start to install it, they will put it for a test period of another 6 months. So basically, between the time the new algorithm is published and the time it's actually in the network, there might be a 1 or 2 years gap, right? Now imagine if it would be the same for a Windows exploit, for example. So those vulnerabilities are actually, they exist, but in practice you need, it's not very practical. You know, if you have to clone a SIM card, you will be able to intercept the traffic over the air, etc. You don't know where that SIM located. It's not that easy, right? It's kind of heavy work. However, there's some interesting signaling information that is sent in clear text and that can be intercepted. So it's part of the authentication exchange. For example, you can intercept the emails and the IMSIs, well, basically serial numbers of your phone can be intercepted over the air. And there are even some hardware devices that are specialized for that. You can also intercept SMS traffic. SMS traffic is not encrypted until the very recent version of the A5/3 algorithm. So all the SMS traffic is in clear text. In practice, however, you must understand that that traffic is carried over TDMA, time division multiple access, and you need some serious equipment to receive it. So it's not very practical for anybody to do that. It's not that difficult either, because you all have TDMA monitoring devices in your pocket, right? Your mobile phones, if it was modified, could very well do this kind of interception. However, the standard models that are sold by manufacturers do not have the intercept traffic feature, obviously. So how do you access those radio network elements? You can access this over MML, and MML, I just want to clarify what it is because I'm using it several times in the speech. It's a man-machine language. It's an interface that is found in all the telecommunication network elements. It's basically a text-based interface where you can check the configuration, reconfigure, modify the parameters, etc. It's like a maintenance language for network elements. So once you get a connection to that MML interface, you can pretty much reconfigure the device at will. You can also configure it using the Q3 protocol, which is a kind of a remote management protocol introduced by the CCIT team. And sometimes they have remote terminals that, for example, just a serial port connected into a modem for people to remote troubleshoot those radio network elements. And they all talk the signaling protocol SS7, so they could also be accessed using that. However, from my experience, if I had to compromise a telco, I wouldn't go for the radio access network because it's just too complicated. There are easier places to do that. Just a quick look on the protocols. The radio protocols are the ones that you talk between your mobile phone and the base station. And there's a few of them. There's a physical channels and transport logical, etc. there. The telecoms are very much into the OSI model. They love those 7 layers, protocols, etc. It's quite different from TCP/IP, right? And once you've accessed, that tower with your mobile phones, then you're talking transmission protocols. And transmission protocols, they basically combine all the traffic of all those base station, all your phone traffic into some big pipes. And those big pipes are moved around into fiber optic rings or microwave ring, and then they are sent for switching. So the radio interface is basically 2 things, right? Radio access and then radio transport. Now, just an example of an attack that you could do over the radio access, right? You could use a fake BTS. I've put a picture of it. A fake BTS is a fake base station. BTS is a base station transceiver. Basically, you are introducing a network element that doesn't belong to the network at all. It's just yours, but it can speak the protocols of the GSM network. So, for example, you could put a fake BTS near an airport or in your car, near some busy area, where people would be setting up phone calls, and you can intercept. And what you can do the man-in-the-middle attack. It's one of the attacks that you can do, right? So you connect a fake BTS to a modified mobile station, and I'm not going to go into the detail, but you know how man-in-the-middle attack works. There's one side believe is talking to another side, but in fact there's someone in the middle that just replays the traffic. Now everything is supposed to be encrypted, but because you sit in the middle, then you're actually able to see the unencrypted traffic. It's a bit like, you could do that with SSL web servers. There are some tools to do that. I'm sure some of you are familiar with it. And so basically you're making an SSL connection and you feel you're talking to a web server, so everything is encrypted, but the guy that's in the middle is getting all the traffic. Well, it's the same here. There are some special commands to ignore encryption with the base station, so you actually force one side to drop the encryption, and relays that to the other side encrypted. So you're able to intercept the authentication exchange and to some extent the authentication vectors. So that's what is used to do, for example, over the SIM cloning, but it's kind of advanced, right? You see, you need very specialized hardware, right? Some other attacks that you can do on the radio network would be to basically connect using MML and then screw up everything, right? Or maybe you feel that your house doesn't have a very good coverage and you just want to increase the power level on the base station, right? You could do that as well. Now, when we move up the layers, now we're leaving the radio access, we're going to talk about transmissions. Transmissions are basically, as I said, the fiber optic or microwave ring that connects everything together. Those are the big pipes for network operators. They operate in, of course, a gigabit per second range. They're using sometimes ATM as a transport layer. They're using also those technology like SONET, SDH, PDH, dark fiber, you might have heard of it, free space optics. They carry IP traffic sometimes, but they're not IP based, right? They're lower layers than TCP IP. However, as I anticipate that this will change as IP become more versatile in network operators, they're going to maybe using it. The problem with TCP IP traffic is that you don't have the same quality of service as you can have in those lower layer protocols, right? Synchronization is very important in a GSM network. And those protocols allow a very, very precise synchronization. Same stories, they can be accessed over MML. If you access one of the main transmission nodes and you shut it down, nothing will happen. Because the telcos, they double everything, right? So if you shut down one node, it's going to route around it, just like if you would be shutting down one router in an ISP, not put it down entirely. However, by shutting down a few of them, you would probably put the network out of service. Now, that has a lot of consequences because a mobile operator is basically making, I don't know, it depends, between 20 and 15 million ringgit per day, maybe in whole revenue for an average operator. So you see an error might cost them 1 million ringgit, right? So when a denial of service costs you 1 million ringgit per hour, believe me, you get people's attention. So transmission would be a dangerous thing to hack, actually, because it affects so many people and you could shut down the entire phone network. How do you actually intercept transmission physically, right? You could, like that poor military guy in that hole. I found that picture on the net. I don't know actually what kind of military is doing that, but just to show you the kind of people who usually mess with transmission, right? Now he's obviously splicing some fiber optics, right? You know, people tell you that fiber optics cannot be intercepted and it's very secure, speed of light, etc. But in practice, there is equipment to do it, right? In practice, there are guys intercepting fiber because that's where all the data moves, right? I was telling that to my colleague Philippe yesterday, and he was telling me he knew some guy who was doing the job in submarines. They were actually digging into the fiber optic relays under the water and installing this kind of splicer so they could intercept the traffic. I wonder what kind of friend he's got, but anyway. You also have a microwave radiation leak problem. You know, the microwave is a very directed traffic thing. It's point to point, you need a line of sight. I remember actually in KL when we were building the transmission network, we had a lot of problems with the line of sight issues because there was those cranes popping up all the time and moving around and cutting the transmission paths. So it's very directed link. However, it leaks. So if you have some very specialized microwave interception equipment, of course they are not sold in your average shop, but you can imagine who are using it. Then you can intercept the transmission traffic. Right. Well, now that we're moving a little bit away from the radio and transmission part, we're going to have a look at the heart of the telecom network, which is basically switching. Now, I'm sure all of you have heard of a telecom switch or phone switch, and why is it called a switch? Well, it's very simple because it switches calls, right, between you and somebody else. For a phone network, you're all connected to it. A typical phone network has a few million subscribers, and basically you're just switching call from one subscriber to the next. Uh, so here you've got the same story. We've got the radio access network that you can see. Where's my laser? You can see on the left side that we discussed about. And then you've got the core network, which is where the switching is done. The packet switching is done, as we said before, SGSN, GGSN, but this is not really the phone switching as we understand it. The real switching is done in the MSC. This is where your calls are switched. There's a big switching matrix that basically interconnects all the calls. So the MSC receives the radio traffic from the radio access network and then switches it here. And it's of course interconnected with the PSTN, with the normal phone network. This way you can call the fixed line and you can call other operators. Otherwise you could only call the network you are on. So the mobile switching center, you know, I've shown you a picture earlier with all those racks. It's usually a very, very large platform, right? It's usually in a country like Malaysia, it would be distributed over a dozen sites. Each site would contain a multi-million-dollar, highly redundant architecture that is basically never failing. It used to be, it still is to a very big extent on a proprietary architecture. For example, in Nokia, they are using a lot of distributed computers. They are basic computer units like a PC, but they're all in a distributed architecture and a proprietary operating system called the DX200, for example. In Ericsson, it's more of a centralized architecture, and it's called AXE. And there's also some other one, like in the States, they've got the 5ESS and many others. In the industry, we call them farm machinery because they're so, I don't know, they're so ancient in their design. Not really ancient, I mean, they're only 10 years old, but you know, when you consider the evolution of the TCP/IP and internet technologies, well, the digital telephony is evolving very, very slowly. And the architecture are very traditional, using the OSI protocols, you know, the telcos didn't know about the internet until last year or something. So, what else is working with the switch? When in a mobile environment, unlike in the fixed line, you need to be authenticated, right? In the fixed line, you're pretty much authenticated by your location, right? Your fixed line is connected to your house, and that's how they know about it. When your mobile is different, so they use this HLR, the home location register, to authenticate you. They know about you, and so they can allow you to make phone calls. And you know, there's also the concept of roaming in those digital networks, right? When you roam, you're basically using someone else's network, most of the time in another country, but sometimes it can be in your own country. And when you do that, well, the visited network has to request to your network if you're authorized to use the service or not, right? So for that, they're going to talk to your HLR. So HLR is a very important part of the GSM network because it contains all the subscriber database. What did I say here? Yeah, we're using TDMA and GSM, and another digital telephony protocol is called CDMA. Actually, they just differ in the way the spectrum is accessed, right? TDMA, as the name says, it's divided in time. You know, all the data frames over here are in small time slots, and CDMA is like a big matrix, code division access. CDMA is actually going to win in the end, I believe, right? Don't tell that to the GSM guys, they'll be very angry, but I think it's better for data. And the ultimate goal of everybody is anyway to move to the wideband CDMA protocol, also called 3G. So GSM is going eventually to evolve towards CDMA in one of its forms. The MSC can be accessed by MML as well, and it's very well connected. It's connected to all the network elements, so you can access it over SS7 as well. It talks those funny OSI protocols like FTAM, File Transfer Access and Management, which is the FTP protocol for OSI, right? It also talks CMIS, which is a configuration protocol. And I mean, it's funny because FTP has very much evolved in the TCP/IP world. I mean, now we use secure FTP and things are pretty well secured, but FTAM hasn't changed since it has been designed, right? I think that the same with all the telecommunications protocols. They take so much time to evolve, and that's why the security problems that were there 10 years ago are still there today. The HLR as well can be accessed over MML and SS7. Now, as you can see, it can get a little bit more complicated. Now, I'm not planning to make you go through all that architecture, but what I'm showing you here is vastly oversimplified. The design of a digital network, and this is just a small part, right? This would be just switching related things, right? Just the radio planning itself, it's a real science. The people to decide where the towers are put, how much power to put on each one, what angle it should point at. It's very advanced technology, and it's very complicated. Once you've planned the radio network, you need to plan the transmissions network, which is a lot of capacity planning into it, redundancy, high availability. So many networks to be designed. So that would be the switching network. So we can see the MSC in the middle that is talking to a lot of other machines. So when you see that, you're kind of amazed that you can make a phone call and that it works. And that you notice that it works almost every time. Okay, sometimes you've got drop call because of radio problems, but on your fixed line, when was the last time that you were talking between two fixed lines and it didn't work? Never. It always works in telecoms because they double everything, and also because they don't use Windows. They run everything on Unix. Now, I'm not joking. Just go into any telco and ask them, where are the Windows machine? And say, oh yes, the mail server is there, and that's it. All the other things will be either proprietary operating systems, like the MSC, etc., or big Unix machines, running Oracle and specialized software. Why is that? It's because they want it to run. They're running a mission-critical environment. Usually they have regulatory constraints from the national authority that say that it must work all the time, so that, of course, precludes Windows. Some example of attacks that you can do by compromising the MSC or the HLR. Well, you could create a lot of funny things into it. You could create, for example, some special forwarded numbers that, imagine you like to call your friend in whichever country, in Russia, for example, and you don't like to pay the toll charges to Russia because it's very expensive, so you just create a forward number in the switch, say when I call that local number, it will forward to Russia. So every time you need to call your friend, you would just call that local number. Of course, you would have to take more precautions but in practice you could do that. It's quite easy. You could make some what we call forwarding loops, right? You can create some special forwarded numbers that will avoid charging and will allow you to either create loops so people can talk to each other by just dialing a number, or in the case of fraud, you can use the forwarding feature of your phone to repeatedly set forwarded calls. I know that some people, when they get access to a GSM phone that's stolen or whatever, well, they will resell the calls. They call the call sale operation, and to do that, they use the call forwarding feature. Of course, even better, you can create a real ghost subscription in the HLR. That's not that difficult. You just need the detail of the serial number of your phone and your SIM, and then you go into HLR and create a profile for yourself, and then the network will give you full access to it. And the good thing about that is because the billing system doesn't know about it, then you'll never get billed, right? You must understand that billing is a very separate process from the network itself, right? The billing system has to know about you, otherwise it doesn't know how to bill you. Now, the switch might still generate billing records for you, but they're not going to go anywhere. And the amount of traffic in a billing system, it's hard to imagine, but imagine how many calls you make every day, right? And how many people in the network are making the same thing. Now, that's how many records are going through the billing system. So if there's one record that they don't know about, they're just going to discard it and they'll never investigate it. They start investigating when they lose $1 million usually. So if you keep it under that, it'll be okay. What you can do also in the switch, you can do some special CDR generation rules. Now the CDR, the charging data records, basically every time you make a phone call, it issues a CDR that you've called from A to B, that time, etc. Right? Those are the call tickets, the call tickets, as we call them, the charging data records. Now you can create some special rules that when you call your friends or when you call from that number, then the tariff would be vastly different, or actually you could completely block the CDR generation at the MSC level for a special number. We do that, for example, for the test numbers that are used by engineers. Test numbers just, either they don't issue CDRs or the CDRs are discarded. So if you create this kind of rules for yourselves, then there'll never be any kind of billing record. Of course, if you have access to the MSC, you can also do a lot of harassment, right? You can imagine you can forward all the, I don't know, the police station traffic to your friend's phone or these kind of things, and, or disconnect their line, or connect them to an announcement machine. I mean, you can do all sorts of things, right? Something that is much more advanced, but could be much more powerful, and we'll talk a little bit later about it. It's injecting SS7 protocol messages. Now, SS7, as we said, it's a signaling protocol, but it's also a network protocol like TCP/IP. I mean, at the moment, on the other room, there's some guy talking about crafting some special IP packets to do probably something nasty. Well, you could do the same with SS7. It's just that most people don't know how to do that. Why? It's because the SS7 is a closed protocol, not because the specifications are not available. They are available. It's because you can't access the network. I mean, it's not like you can go to your ISP and say, hi, I want a SS7 access. They'll say, what? But, you know, internet access is so easy now. Everybody's get used to it. You just get an account, and from your account, you just download Nmap or Xprobe, and then you start scanning around, and then you download the latest exploit, and bang, you root somewhere else. Well, it doesn't work the same for SS7. First, you need to secure your own access, and that's difficult. Then you'll have to be able to know all the protocols by yourself, because you won't be able to download a fancy tool written by Fyodor or his friends to scan. So we'll talk a little bit about that later. Now, let's move a little bit outside of the core network. Now, so far we've only seen the core network, right? Radio and switching are basically, well, actually radio is not even core. The core network is where we have the HLRs, MSC, the EIR. It's providing the core service in the telecommunication network. If you removed everything, you would still be able to make phone calls if you would be directly connected to the switch. But however, as time passed by, people wanted to have more services on their phones, right? They wanted to have call forwarding, they wanted to have toll-frees, you know, all this kind of fancy stuff. And in the beginning, that was done with the switch, but after they moved that intelligence outside of the switch, and they created a platform called the IN, the Intelligent Network. Now, the IN is basically usually made on a set of Unix clusters that are talking to the switch directly. And the way it works is during call setup, during what we call the call processing, the MSC will interrupt the call processing, will send it to the IN will execute the service logic, and then resume control to the MSC. A typical example of that is the prepaid service. I mean, prepaid is an extremely successful service, and it's fully implemented by the IN. You know, prepaid, you don't have any bill, so you have to control the credit in real time. The way it's done is, well, it's simple. Every time you make a phone call, control is sent to the IN. The IN is checking a database saying how much money does it have in its balance. If there is enough money, continues the call. When the balance reaches zero, you know, drops the call. I'm sure most of you are very familiar with prepaid. It's been an extremely popular service for operators. You know why? Because in the beginning, they just wanted people with good credit records, so they get paid. After they invented the prepaid, so they could give access to people with poor credit records, right? So that's why it's successful, because it basically accessed a segment of the market that was not accessed before. Now, the good thing about this IN platform is that it's connected to the IP network, because it needs to talk to other network elements. And it's connected to the SS7 network, because it needs to talk to the switch. And it's controlling all the services in the mobile phone network. So it's a very interesting place to actually commit some sort of sophisticated fraud. As we'll see in the next slide, I think I've given some examples of attacks. It's talking the SS7 protocol, was a sub-protocol called INAP, Intelligent Network Application Part, which is kind of a high-level protocol for call control. So let's move to the next slide. Well, yeah, okay. No, that's fine. So this is just to show you where the IN would be sitting. It's not very clear here, but it's sitting, you see on the upper, where's my laser? Right here, you've got the service control point, and we've got another service control point here. Those are part of the IN. The IN is made of many different network elements, but principally it's SCP, SSP, and SMP, the service management platform, service control point, and the service switching point. So the service switching point interrupts the call, transfers it to the SCP that executes the program logic, and everything is managed basically by an SMP. So Let's go to the next slide and have a look at what kind of attacks you could do on IM. Well, the first very easy, well, easy once you have access, of course, right? There's no dial-up to the IM, although sometimes you can find some. Is just go to the database and modify the prepaid balance. Because when you have a prepaid phone, you know, imagine suddenly you put 10,000 ringgit to your phone, or you have a little script that puts 10,000 ringgit every week to your phone account, and first it will very, very seldom be detected because there's so much data moving around that most operators do not have time to notice this kind of things, and you'll get basically prepaid credit for life. Well, if they do their job properly, eventually you will get caught, but since you're a mobile phone, if you do things properly, you might avoid going to jail immediately. You could also create some special toll-free numbers. You know, the IM is used to create toll-free numbers. You know, those numbers that you call and have no charge, so you can create your own toll-free numbers and call them whenever you need. It's a very convenient place also to intercept subscriber activity. Because since now half of the subscribers are prepaid in a typical network, and the IM will record everything you do, then you could have an interesting intelligence gathering from if you trace some subscribers. The IM would be a good place to do that. You could also create a fake service. Now that requires that you know how to create services and have access to the service creation environment. But if you do that, you could be completely invisible in the network. You've got your own trigger, your own service that execute God knows what, but you're the only one to know about it. Because the expertise in IM is very spare in telecom operators, it's very unlikely to be detected. It's not for the beginners, though. The IM is also having some tariff tables because, as you know, you can make prepaid calls to anywhere, so it needs to know about the tariff. So you could also modify that. The CDR generation and also how the tariffs are charged. You could also create some special forwarding things. Some operators, for example, cannot charge for prepaid forwarded calls, so of course they block it at the HLR. But if you unblocked it, you would be able to do forwarded calls and not be charged for them because the billing system doesn't know how to handle them, for example. And you could also create some unauthorized supplementary services. For example, if your operator has said, okay, your prepaid users do not have access to GPRS, okay, and if you modified that and said, well, I will have access to GPRS, then they'll never be able to bill for it. So if you create unauthorized supplementary services, then you'll be able to access telecommunication services, you know, without being charged, basically. Right, another aspect of the network is the SMSC and MMSC. Those are the servers that are going to basically send you short messages. I'm sure some of you have heard about the MMS protocol, which is basically short message plus multimedia features. Not much different. I've just put those gross figures as an illustration of how successful messaging is. Now, what's interesting is that initially the GSM people, they didn't think about SMS too much. They just put it as an add-on, you know, like last minute thing. Oh yeah, let's put that little SMS thing on the signaling channel, and maybe somebody will like it. In the beginning, operators were not even charging for SMS because they didn't know what to do with it. You know, it wasn't popular. People said short message, yeah? And then it became so popular that, of course, they started charging for it, and you can see the growth, right? SS7 is used as a transport. It's basically using a signaling channel to transfer your SS7 messages. That's why you don't need to set up a call. You don't need a speech channel to send a short message. Your telephone can be in idle mode and send and receive short messages. The way it works, the signaling message is relayed from your phone straight to the SMSC where it's basically stored. It's a stored and forward mechanism. Your message is received and it will be sent as soon as it can. That's why sometimes you have delay when you send a short message to your friend and they say, but I only received it yesterday and you sent it 3 weeks ago. Well, it's because someone didn't do his job properly at the operator, or sometimes it's just overloaded. Overload can happen. For example, you see your short message taking 5 minutes instead of 5 seconds. It's because the SMSC server has so many messages to handle that it's basically overloaded. Telcos are always fighting, it's a race between investment and overload. They always have an increase of traffic. They need to handle that by buying new equipment. So it's a fine balance to find. Also part of messaging, which is not part of the GSM specification, but is used by every GSM operator, is the voicemail. Voicemails is also interfaced using SS7 and voice trunks. Well, you're all familiar with voicemail, I don't have to explain what it is. Let's have a look at, let's have a look at how SMS has evolved first, just to explain you why things become so popular. It's because first they are a very basic service, and then everyone is using it, and then they start doing things like, m-commerce, m-banking, email, prepaid, ringtone, local text, voting, and whatnot, chat, find a girlfriend through SMS. I mean, everything's possible. So of course, when you have that, it means you need more servers. Those servers are more and more interconnected with external parties. In the beginning, everything was run in the operator, in their own SMSC. And eventually they say, well, for the ringtone, then the guy is going to connect to the SMSC so he can send the ringtones from another company. And then another company will provide m-commerce, and then the bank will connect for whatever, right? So you'll have all those companies that are connecting to the SMSC. And that increases the risk exposure, of course, because the SMSC is connected to the SS7 network. It needs to send and receive signaling messages, because that's where SS7 comes from. The SMS messages are transported over SS7. It needs to talk to the HLR to check things. It needs to talk to the IP network to be able to handle all those services. So that makes it a very vulnerable point of entry in a network, because it's connected to all those external parties, right? So you don't have to necessarily hack the telco infrastructure, you just need to hack one of their ringtone partners, for example, that might not have the same security rules as the operator itself. Yep. So what kind of attacks could we do on messaging? Well, the first obvious thing is that you want to read what your girlfriend is sending as a short message, of course, right? So you will go there and intercept all the messages. It's very easy. It's a database running on a Unix machine usually. It's indexed by numbers, so it's very easy to actually see the messages. I remember one day I was troubleshooting an SMSC, and we had to look in the messages because it was part of the trace. And well, you'd be very surprised what goes on to those. I mean, the messages are just incredible. Another problem that is starting to appear on mobile phone network is the spam. People are setting up their own SMSC somewhere, interconnected to the SS7 network, and start sending spam. Now, it's not very much developed. At the moment, the spam is mostly by the operators. Like I arrived in Malaysia yesterday, and I got a short message saying, welcome to Malaysia. In case you don't know the country you are in, it's going to be mine. But more and more, they are sending commercial messages. Our promotion this, promotion that, etc. And of course, if they do it, then other people will do it. And I'm sure you all love having those hundreds of spam messages in your inbox. Now, think about how you're going to log them on your phone. You could, of course, modify your telephone to send some SMS that are not formatted properly. There were some, for example, there was some buffer overflow. Well, I suppose it was based on buffer overflow, but if you send some specially crafted SMS message to some phone, that would basically make them reset or crash, etc. So you could do this kind of nasty things. For the voicemail, the VMS, well, it's also most of the time running on a big Unix machine. It has some fancy features like call redirection or out dial and things like that. So sometimes they can be abused for getting free calls in a particular way. Another part of messaging that probably you haven't heard about is called USSD, the Unstructured Supplementary Services Data, which is like an SMS message, but it's much more limiting the number of characters that you can send. But with multimedia, then suddenly not only you have the length of the content that you send, but you have also the encoding, right? So if you send some JPEG or PNG or GIF, it has to be decoded and rendered. Same for the audio, same for the video, etc. So suddenly you have access to more vulnerabilities because the manufacturers, they're always in a rush to send out their products. So you can be sure they have some application with problems. Those problems are not typically published because most people do not play with MMSCs and the way they render and display pictures and forward them, etc. But they will. It's interconnected to the IP network, very much so. It's also interconnected with the value-added services network because it needs to provide those value-added services. So we basically have have the same problem as the SMS, right? Eventually people will use it for spam. Eventually people will use it to send messages that they're not supposed to send. And because they are connected to a lot of external partners, they've become a vulnerable target. Right. Now here I've just found that on the 3GPP, which is an official organism that, or kind of entity that regulates all the GSM and 3G things. And you can read what they say, right? They basically say that, yeah, it should be secure like this, it should be secure like that, right? I mean, it's a bit like, you know, you deploy a database and they tell you, yeah, your network should be secure and your door should be closed and there should be an alarm system on the door. Basically, they're telling you that we are going to rely on somebody else's security to provide MMS security. Now, in practice, MMS security has a lot of problems. It's relying on some protocols that have weaknesses. Some of the communications are not encrypted. Some of the communications are not authenticated. It's, you know, every time they say, all right, if you speak to the switch, you know, you speak to the switch using the, well, what we call the MAP protocol, which is a sub-protocol of SS7. So they say, well, you just have to use MAP security. When you use IP traffic, well, you just have to use IPsec. That's nice, right? But in practice, people will not deploy MapSec and they will not deploy IPsec because they've got other things to do, and because the protocol is not mature, and because they don't know how to handle the key management problem. So, you know, it all looks good in practice, but it's not. DNS security is the same. They say for DNS security, why don't you use DNSSEC, which is a protocol that maybe 0.01% of the people are using in DNS, right? It's using WTLS sessions, so there's this problem like with the web gap, as it's called, you know, it's the same as man-in-the-middle attacks. You can force the use of other gateways by some special protocol messages. Blah, 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 blah. There's no proper certificate on key management. Of course, it's a very difficult thing to do, so they don't do it. They say use SOAP security for transaction, but most of the people don't implement it. And they didn't really address the issue of the hostile user agent. Now, a user agent is basically your terminal, your phone, right? Your phone is supposed to send very strict MMS protocol messages, but if you modify it, then you can do a lot of nasty things, starting with spam. And SMS spam is going to be, I think, a problem, because not only you have to, you know, someone has to pay for the message, as opposed to the internet, where spam is basically free of charge to send. So, well, someone is going to find a way to exploit the MMSC vulnerability so they can send spam for free. That's going to be right. And I found that quote in this MMS security consideration from 3GPP, and it says, read it out, currently the majority of handsets are based on closed operating system built on more or less proprietary hardware. To this extent, this acts as a protection against buffer overflow attacks that try to execute the malicious applications. Yes, right. It's like Windows, 10 years ago they said, well, there's no buffer overflows in Windows. Look around, no one has found any. Of course, it's closed source, right? So it took some time to people like Harvard to use IDA to basically automatically find buffer overflows in code. But now you've got a lot of them. All the worms that you've been seeing around, they were because of a buffer overflow or heap overflow in Windows, right? They were discovered. It just took more time. In Unix or open source stuff, you just take the source and you parse the source. You try to find where are the vulnerabilities. It's easy. You have the source, right? When it's closed, it's more difficult. But it's just obscurity, right? It's not going to protect you at all. And I find it a bit worrying that people still keep making the same mistakes. But anyway. Right. So next thing we have to talk about is packet data. So packet data is, as we said, it started with a very small data rates, 9.6K, and now it's, well, 3G is promising you 2 megabit per second, and they even have faster, things like that. At the time they conceived 3G, 2 megabit per second sounded very, very, very fast, right? We were talking kilobit per second at the time, right? Now that you've got wireless LAN running at 54 megabit per second, and suddenly the 3G speed seems not that exciting anymore. But at the time it was conceived, it was really considered fast. Remember, they always lag, the telcos, right? So what did they do was they started integrating the wireless LAN protocols in their network, right? We don't think that you guys using Wi-Fi are going to take some revenue out of the operators. No. They're going to integrate the technology so they can charge you for it. Yeah, well, actually, I'm not going to speak about because at that time there was supposed to be a guy called Ollie Whitehouse who works at Stake, and he's the best guy about GPRS and 3G security. And he was supposed to make a speech, and I was very much looking forward to hear, but he couldn't make it because of some work engagement. So I'm not going to steal his show. I'm sure he's got more opportunities to present the paper, so refer to it. Okay, still going up as a layer in the telecommunication network. We've seen the radio, we've seen the switching, we've seen some of the services, messaging, and now we're going to move into the management. Every network has to be managed, right? If you have an IP network, you do that with OpenView or something similar. When you have a telecommunication network, things are much more complicated, especially your mobile networks. You know, you've got to be able to access every single tower, every frequency, every base station, transmission. Actually, everything has to be managed in real time. Because operators must provide a service that works all the time. So they have usually a big network management center that is having a lot of screens monitoring the network. They have 24-hour staff. They have people on call that goes to the site if it's got a problem, etc. So you have this application that we call NMS, Network Management System, or OSS, sometimes also OMC, Operational Maintenance Center. Whatever the name, it's basically a very large cluster of Unix machines that is talking to the network and taking the measurement from the networks to be able to see what the problems are, the alarms, the events, and is able to send configuration actions to the network. It's basically a super platform that controls everything. It's not critical to the service itself. If the network management system goes down, you will not notice it on your phone. You'll still be able to make calls. It's just that suddenly all the operators will become blind. Things will still work, but they won't see the traffic. So it's quite an important platform. The good thing when you have access to the NMS is that you can control every single device in the network. You can do absolutely everything. You could start by reconfiguring some radio thing. You could really do a lot of things. I think the next slide I have some example. Yeah, you could do a denial of service on any of the network elements, shut down a radio station, shut down an MSC. I mean, shutting down an MSC would cost millions to an operator. It's really something not to do. You could steal a lot of confidential information because all the network design is in the network management system. And believe me, it would be worth a lot of money to the competitors. Because it's connected to every element in the network, it means you have access to all the authentication information because they don't even know about SSH in telcos, right? Telnet is a strong protocol there, right? So everything is stored in clear text. SQL scripts have the password of the databases, etc., right? It's got access to the private X25 network that interconnects all the network elements. I mean, it's got access to everything. It's really a very, very friendly network to access, system to access. And because it's used by the maintenance people, and those maintenance people, they're not always physically present, so they need dial-up access. So they will have a lot of dial-up servers for the NMS. Sometimes they will not use strong authentication methods, so you can guess the rest, right? And of course, it has all the function for subscriber tracing, and this time in a very user-friendly way, right? You can really just select a number, enable tracing, get the tracing reports, including where that person was, what phone numbers, etc. So it's a very powerful platform. It is the most powerful platform in the telecom environment. Okay, now we're going to move a little bit away from the telecom side. Traditionally, an operator is divided between engineering, which runs the telco side, and IT, which runs the billing system and mediation. Now, I've put a little diagram to just show how these things interact. The billing system is not essential to the network. It would pretty much run without it. You could still make calls, but guess what? They couldn't be billed, right? It happens sometimes. When they have problems with the billing system, they would rather have people make free calls than tell them there's a billing problem. So on one side, you've got the customer care and billing system that maintains all that big charging information, and on the other side, you've got the core network that generates CDRs, call tickets. Those CDRs, charging data records, are transferred from the network to the billing system using the mediation device, which is more than a single device. It's usually a large network of file transfer machines that just relay CDRs, sometimes format them, aggregate them. And on the other hand, another thing that mediation is handling is the commands from the customer care, right? Like activation, cancellation, modification of services. When you call your operator and you say, I would like to cancel my phone because it's been stolen or whatever, they're sitting on that side and they're going to have night graphical user interface and they're going to say, cancel that subscription. Well, that thing is going to be transferred into MML commands for the network to remove the subscription from the HLR, etc. So what does that tell us about mediation? That tells us that mediation is basically in the middle of the billing cycle. So all the money is going through there. And it's also sitting in the middle of activation, deactivation, and service modification commands. You get access to all the configuration of the network. So that's a convenient place. In practice, the mediation and billing network is a little bit more complicated than my simple diagram. So just wanted to show you that it's not as simple as it looks, right? Actually, billing, you think it's simple, it's very complicated. I couldn't believe how complicated it was. And it's a miracle that you receive a bill, but it's usually the network element that works the best for some reason. Of course, the money is involved, right? Okay, well, let's not get into this. Okay, but what kind of attacks could you do if you have access to mediation or billing? Well, the first thing, if you're a little bit of an SQL guy, you go to the database and say, well, delete, charges from that number, etc. So you can easily edit the billing data. And if you do a raw database edit on the billing system, no one would be able to see that. I mean, they hardly understand SQL themselves over there. You could change the charging tables in story. You could change the application that is rating the calls. This way you could have it, for example, rate your calls in a different way than everybody else. You could put some backdoors and remove the CDR data. You could put, for example, a nice filter in the mediation. Say, if I see a CDR coming from the network with that mobile number, I would just dump it. So the network would generate the charges and say, I'm doing my job. So mediation would just discard that charge. And the billing system would say, well, I've never seen any of those charges. So basically, you'd be making free calls. The billing system would be happy and the network would be happy. Of course, it's a good way to get confidential information. For example, I've been involved in some fraud investigation where the staff of the network operators were using the billing system to give confidential information to other people, say, investigators or something like that. Say, we want to know what number has been called by that guy, etc. There's a lot of privacy involved. You could, of course, create some test numbers. Test numbers are, telecom operators, they are like a whitelist, that not to be charged. We need a lot of test phones to make all sorts of tests, roaming tests, etc. So you could put yourself on the whitelist. You could live patch the CDR data while they are transferred, but that would be a little bit complicated. You could also modify the application that runs the mediation. I mean, basically, you are in the middle of the network and the billing system, so you can imagine all sorts of things that you can do. From my experience, the mediation and the billing system vendors, they are not very glued to security, and they use old software techniques, they use old script, old methods. Security is never their priority. They don't have time for that. They always assume that it's a closed environment, it's secure by default, so they don't have to implement security in it. Which is actually, it made sense a while ago. It's like banks, right? First they said, yeah, we're secure because we're closed, but after they have to open everywhere with e-banking, etc. So suddenly there's a lot of banks that are getting hacked. Same with the telcos, with a little lag. Actually, they have a word for that in the telcos. When you modify CDRs, etc., they call it revenue leakage. And revenue leakage is not something you stop in telcos. They know there's always revenue leakage, either because there's configuration problems, or because the engineers, they don't like to pay for their calls, or because there's some bugs, or because there's some fraud. They just want to keep it at a reasonable level. So they will implement fraud management systems, they will implement all sorts of platforms to sort of reduce that percentage. But the revenue leakage is always there for telcos. As I said, they're not interested to hear about a problem if it's under $1 million. That's usually the number that gets their attention. Typically, an operator that doesn't have any fraud management system will have, I would say, 7 to 10% fraud of its revenue. So that's huge. We're talking, tens of millions every month, right? And when they put it down to 2-3%, they're usually happy. 10 minutes to lunch. I have to increase my pace. Right, okay. Legal interception gateways, that's a machine used by the police to intercept your calls. They can see all your traffic, all your short messages in a very real-time friendly platform. So that would be an interesting target. And if you compromise it, you could, as a benefit, compromise also the police infrastructure, which they might not like the job. So let's go quickly over the slides. Yeah, one thing that's important, that I said your phone is a computer, and a computer can have application uploaded to it. There's various protocols to do that. We call them over-the-air protocols because basically the OTA server can send an application to your phone. If you're using a GSM phone, it's a SIM toolkit application that can run all sorts of SIM. When you're using 3Gs, and it's even more complicated. You've got the full operating systems and etc. So if application can be uploaded, you can imagine that a bad guy can also upload bad applications, right? Yeah, I talked about the authentication vectors, the KI, your secret key that is stored in your SIM and also stored in the network. Well, rather than trying those very advanced cryptographic methods to get your KI, you just go to the network where it's stored, and usually it will be stored in clear text. They will transfer it using FTP. They will have multiple copies of that file lying around, and they will sleep fine at night because they say, oh yeah, but it's encrypted in the SIM, so it's fine. Right? What they forget is that they have 20 copies of the same file lying around the network. Anyway. Yeah, I think the part on SS7, I'm going to speed it up a little bit, but SS7 is a signaling protocol. We've talked about it in the first place. Now, you must understand that it's a very large network. It's larger than the internet, right? There are more SS7 nodes than there are internet users, simply because every mobile phone is an SS7 node, right? So this is a network that is larger than the internet, that has been around at least as long, that is not very strong with security, yet nobody that I know has compromised it, because it's difficult to access, right? But imagine if you get access to the telecom infrastructures and you get access to the SS7 network, and if you start developing tools to scan, probe, or exploit SS7 vulnerabilities, then you're going to be able to compromise basically almost every telecom operator in the world, or you would be able to remotely shut them down or things like that. So there are very nasty consequences of using SS7. And the kind of attack that could be done with SS7, as I said, they're not common at all. It requires some knowledge to do it, but I expect that this knowledge will increase and people eventually will get interested. You can intercept credit card numbers, you can introduce harmful messages, you can do denial of service, you can have free calls, access to emergency services. I mean, you control the network. When you start to inject your own SS7 messages, you control it, basically. The way it works with SS7, you've got the STPs, or the equivalent of routers in TCP/IP. And it's basically a protocol that can be routed like TCP/IP. I mean, remember, TCP/IP started as a simple protocol, and then people started talking about IP spoofing, UDP spoofing, TCP spoofing, etc. All those vulnerabilities that came because people studied the protocol and started making tools to exploit those vulnerabilities. Well, in SS7, the vulnerabilities are there. It's just that they haven't been exploited yet because there hasn't been any sufficient research for it. You know, TCP/IP is so popular because it's accessible on the internet. SS7 is also used in VoIP, which is a very interesting topic that we won't have time to speak about the security of it. It will require an entire new speech. But basically, to put it short, voice over IP has to talk to the IP network and has to talk to the PSTN, the phone network, right? And it talks to the phone network using SS7, and it talks to the IP network using TCP/IP. So voice over IP is a point of convergence between the two protocols. So they start having new protocols like SIP and SCTP, and I know some people who have already developed a SCTP scanner that can scan the internet for voice over IP gateway. Anyway. Right. Yeah, I found a quote on the internet by some big government report in the States saying that there is a realistic chance of forcing an outage of large scale that most operators will be unprepared to recover from it. Now, SS7 is a basic infrastructure. It's like your power grid, basically. It can be attacked in the same way, and consequences could be disastrous. I mean, it could also use that, if you could shut down the telecommunication services for an entire country, it certainly gives you a lot of power and a lot of problems. There are security solutions for SS7, but I mean, it's pretty much like security solutions for IP in the 80s, right? Yes, there are SS7 firewalls. I think I was able to find 2 on the internet, and one of them didn't even exist anymore when I tried to connect to the website. So imagine you're in a world with a huge data network where there's only one firewall vendor, where maybe 1% of the telcos have deployed it, and yet no one is hacking into it. It's kind of amazing. Right, next slide. Yeah, basically I have to rush this, but I explained that SS7 is a closed network, and that's why it is reasonably secure. The way it works, there's always 2 networks in the country. There's a national SS7 network, rather than, it's like there's a network address translation between the two. It's like a private IP and the internet, and there's NAT in the middle. Well, it's a bit the same with SS7. There's an international SS7, and it's connected to the private SS7 network using global title translations. And there will be a lot of interesting scanning tools that could be developed to scan the global title translation. However, things are changing. As I said, the voice of your IP platform are starting to push integration SS7 and IP. A lot of providers are providing SS7 services. The IP world is basically merging with the telecom world. And what that means, it means what was closed is actually becoming open. So what they assumed in the beginning, saying we don't need protocol security because we are in a closed, secure environment, well, it's not true anymore because now it's being open everywhere. Let's skip the protocol stuff. Oh yeah, but that part on X25 as well. Jeez. Wow. Skip that one. Right. Quick word on X25. Right. X25 is probably something you've forgotten about, but it used to be a very popular protocol at the time. I would say late 80s, early 90s. I can see Anthony smiling. Yes.
Who was that famous X25 hacker?
Well, there were a few of them, and I think you're one of them. So. Anyway, X25 is a data protocol that was very ancient. I think it was the first global data network deployed. It's being used everywhere. You don't know about it, but it's being used by banks. I mean, every time you make a bank transfer, it's using the SWIFT network. It's based on X25. It's used by airlines. It's used by telcos. It's used by governments. It's interconnecting everything everywhere, yet everybody's forgotten about it. I mean, I remember in the early 90s, it was all the rage for hackers to hack X25. And it was very elite because X25 is also a closed network, and all the calls are charged, so you first need to be able to access it before you can do anything. That was not like the internet where you just get an ISP account, right? So people have developed scanners for raw dialers for X25, which you can see an example of an output. You have NUAs, which are network user address, and then you see what you connect to, and then you can find all sorts of funny targets on X25. It's still very much active today. I mean, X25 is used everywhere, and very often you would have an X25 connection right inside the company, bypassing all the firewalls, because the IT guy, he doesn't even know what X25 is, and he doesn't firewall it. The hackers can only come through TCP/IP, right? Okay. As you can see, it reaches everywhere. This is a Iran PAC X25 network. I think it's quite a long picture, but I think it's cool. Even in Iran, before they had the internet, way before they had the internet, they already had X25. And a quote from one of my friends, 1% of the top 1,000 companies and nations' critical infrastructure with X25 links worldwide are somehow not penetrable. Now that it means 99% are open. Well, you might not be as skilled as Raoul to be able to enter all of them, but it's just to tell you, this is something that is not firewall, that is getting everywhere, and that most people have forgotten, but it's very hacker-friendly. Right, I'm almost not late, let's conclude. Well, conclusion that you can see there's a lot of systems, there's a lot of networks, there's a lot of protocols. If you get bored by using the latest buffer overflow exploit written by someone else, maybe you can start learning about that. A good benefit of learning about phreaking and all this telecommunication stuff is that you might actually get a good job after that. The telcos, they are lacking a lot of good talent. The increasing complexity of application and system like GPRS, 3G, etc., means that things will get more integrated and more vulnerable. The threat is not going to decrease, it's going to increase because we are using more complex applications, and the telcos, they're always in a rush to push everything on the market, and security is usually the last thing on the list. And they are moving from a closed environment to an open environment. I think that's about it, so thank you for your attention. It's been a little bit rushed, but I'll be happy to take any question if there is any.
Okay, I'm Jet. I actually work for Maxis, one of the leading telcos in Malaysia. Just now you spoke a little about how an SS7 network can be compromised via the SMSC by third parties connecting to the SMSC. I was wondering whether has there been any instances of that happening around the world, or any that you know of?
Well, I know some people who have compromised the SMSCs in Europe to access the SS7 network, yeah. I know that I think all of the Northern Europe SMSCs have been compromised to that purpose. They don't know about it, but I know someone who's involved with that. The thing is that the expertise required to mess with SS7 is very, very rare. I think there would be less than maybe 5 to 10 people in the world that can play with that. So don't be worried. But if it happens, call me. Any other question before we move to lunch? Yes, Anton.
Yeah, just one practical question. Every time when I'm coding, right, you'll see, or at least in my mobile, I can see the lock, small lock on the screen, right? And usually it's not locked. Does it mean that everybody can sniff my conversation?
Well, the encryption is an operator decision, right? They can decide to enable encryption on the network or not. Most of the time they enable it. Sometimes when you roam, they disable the encryption for roaming numbers. So that's why maybe here you see you don't have the lock. It means yes, your call can be intercepted. However, it requires heavy equipment. So it's not like you can take a radio scanner and listen in. It's not frequency-based, it's time-based, right? So you need a TDMA listening equipment. So it's actually very unlikely that people will listen into your calls.
How much does it cost to get a TDMA receiver?
Well, actually, yeah, it's a good question. It's not that expensive nowadays. And in fact, you could even modify your mobile phone to be able to do that. Okay. So yes, maybe it's getting... I don't know how much exactly. How much do we charge for? I'm not sure. Yes, a legal interception gateway, yeah. Yes, the manufacturers, the telecom vendors will sell it happily to you. It's part of the GSM standard. No, I mean, they will only sell it to operators, right? And police. I mean, this is, if you go to, if you call Nokia and say, I want a legal interception gateway, they'll just, what? And you need to connect to the MSC, right? There's a special interface on the MSC, on the switch, that basically relay all the signaling to the legal interception gateway, and they're able to intercept all the signaling information in real time, which means all the call setup, SMS, etc. And they also have speech trunks, so they're able to listen in. So they've got a nice graphical user interface, and they put the numbers, and they can click and listen, etc. And even for GPRS and 3Gs, they can intercept all your data session. It's very, very advanced, very user friendly. Yes. My colleague Raul in Italy has been working on the legal interception gateway. Yes, it's a Unix box with plenty of vulnerabilities. So there's probably one at Maxis. Maybe you don't know about it. They don't tell everyone. It's just a few guys in the operators that would know about it. But usually there would be no special E1 interface to the MSC, and then it would be sent using a private network to the police and intelligence departments. I'm pretty sure they have one at Maxis. I think the easiest way to access it would be to just get yourself a telecom license and declare yourself as a telco. It's but it's not that difficult in Europe where it's fully deregulated. You can get a telco license for $10,000. I mean, I know it's not exactly cheap, but it's not very expensive either. And then you can become a telecom provider, and then you've got full connectivity to the SS7 network. If you wanted cheaper alternatives, then the easiest way would be to compromise, to hack into a telco through IP and then connect to one of the machines that spoke both IP and SS7, like SMSC or the IN. Well, SS7 has got many layers, right? You've got the physical interface, which is MTP1, then up to MTP3 for transport. Then you've got SCCP for routing. Then you've got TCAP and upper applications. It's an OSI protocol, right? So it's got all the full 7 layers. Yeah, but as I said, it depends what layer you consider, right? If you're just interested in the physical layers, then you need an E1 interface, the 2 megabit interface, which is the standard. But if you want to hack into SS7, you don't really care about the physical layer any more than you care about the Ethernet cable with TCP/IP, right? So you would work at the upper layer level. For example, if you want to scan an SS7 network, you will be working at MTP3 and SCCP layers, the same way you would be working at TCP layer when doing a TCP/IP scan, right? Yeah, it's the same concept as TCP/IP, basically. TCP/IP is also layered. You've got IP and then TCP, etc. You craft your own messages and you wait for the response. Your messages are routed by the network. When you scan using Nmap a remote machine, all your packets are relayed by the routers, etc. Well, in SS7, they will be relayed by the STPs, the signaling transfer points. So the concepts are exactly the same. And in fact, actually, I would like you to work a little bit on SS7 scanner in your free time. I say that because Fyodor is developer of one of the TCP/IP scanners, so he knows what he's doing with scanning. Any other question? Hungry? Anthony?
You said that ISDN was using SS7. Can we
Yes, you can.
use the ISDN model?
Yes, you could, indeed. The thing is that you will not have the full layers. When on your ISDN phone, you've got access to the sub-protocol called ISUP, the ISDN user part. But with that, you can already do a lot of things. Yes, I highly recommend that you investigate that further. Yeah, for your phone as well. Yeah, if you have access to to special features, you have to be able to modify it.
Yeah, I just wanted to mention, you talked about a legal interception device. Actually, if you want to locate a phone, you just need access to SMSC.
Well, the MSC would be the best way to do subscriber tracing because it contains all the calls.
Anyone who has access to SMSC can locate any phone in the world because you can locate the phone before you send the SMS.
Yeah, but there's one problem though. You won't be able to intercept speech because speech is moving on the speech trunks. And when you're the police, you want to be able to listen in. That's the whole point of interception, right? So you need access to the speech trunks, and that is not done easily. You can't modify the speech trunk configuration without getting physical access, right? So, to my knowledge, it's extremely difficult to remotely intercept speech. Using any way to hack into the operator, you will not get access to the speech channel. only if you've got physical access to it, you're able to modify the way the speech are routed, and it's quite complicated. That's why the illegal interception gateway is so powerful, because they've got access both to speech and signaling in real time. And that reminds me, those movies where the guy calls and he just waits a minute, say, oh yeah, after 1 minute the police can detect me. Do you know that actually this is completely bullshit? I mean, I think this is just to make the bad guy say, okay, I've got 1 minute to talk, but actually no, they intercept you immediately, right? And even if they didn't, the data is stored indefinitely in servers. So. Right? Anybody else? Okay. So I think we're going to conclude, right? Thank you a lot for your attention. And
thank you for introduction. Good afternoon to you all.